Thank you very much for coming. I will present today work of Alexander Tsietkien, is a Russian researcher of interstellar space flights for many years. About 30 years he think about this idea. And the presentation is prognostication of advanced trends in technique and technology of interstellar flight. Alexander Tsietkien, originally from Kaluga, Russia. This is hometown of Tsiolkovsky, as you know, founder of theoretical astronautics. Next. So the work is presented here is about using gravitation as propulsion system. The gravitation as propulsion system could be used in form of micro black holes with relatively low mass, and using gravitational forces of this black hole that is possible exist in the universe and also could be made artificially and accelerator or another way offered by many researchers already. So we can use it as new generation of propulsion for Starship, because what we need now in our progress in space flight is radically increase distances to penetration in space and reduce time travel. We cannot do this with rocket system because it's limited. Where we can go and with what speed we can go, because everything depends on fuel, and we need a lot of fuel to fight with gravity to go out to space. So in this model is theoretical model and theoretical calculation based on general relativity theory and also another physicist. It's presented spaceship in two models. One is active model and one is passive model. Active model is where is micro black hole located or concentrate of mass, and passive model where its crew is located. And the passive model is a permanent free fall to the active model that is gravitational body. So when the active model accelerate or run with acceleration A, the passive model fall on the gravitational field of this model constantly with same acceleration. So G equal A is condition of stability. Next slide. This is condition of stability of this dynamical system, and how we can do this with distance h is safe distance for crew, because when we in permanent fall to other bodies, like you in a falling elevator, you experience only like it's close to 0G gravity condition. So we can achieve huge acceleration and still not overload the cabin with astronauts. And next slide. So this is practically what we see. This is a passive model, and what happened with the crew. Crew experienced the tidal forces by the active model, that is black hole, and distance h between these two bodies. They don't have mechanical connection between each other. They just have distance, field connection, the gravitational field connection. So an equilibrium point is located on passive model, on center of passive equilibrium point of whole system. That's why the crew experience close to weightless condition. And H calculated by H is calculated, the distance between two models calculated by this formula is to achieve the safe forces over the crew. Next slide.
Could you speak into the microphone more?
To the microphone. Okay. Okay, and here we see practically the same, that active model is compact concentration of mass, low mass black hole. The passive model is where the crew is located, and the equilibrium point is the point where vector G and A equal, and equality of vector G and A is a necessary and sufficient condition for the stability of motion of such a dynamic system. Next. Here we can see distribution of the tidal forces. An object placed in equilibrium point will be stretched in the longitudinal direction and squeezed in the transversal direction under action of tidal forces. This is what crew experience in passive model, and this is active model. The value of extreme linear acceleration G is 8 in the managed gravitational tandem limits only by tidal forces. Next. Okay, here we see the field of tidal forces is a superposition of central symmetrical gravitational field of mass concentrated black hole and homogeneous field of inertia force. And on this table you see mass of active model, for example 10 to the 16th kilogram acceleration that is possible for this network. Acceleration G equal 8 possible to not hurt crew is 1,500 meters per second square. And the distance between two models have to be in this case h21.1. If we have a heavier black hole or active model, 10 and 20, in this case acceleration, as you see, is 10 to the 5th meter by second square, and the parameter of h will be much bigger, it's 258 meters, so it will be much bigger ship. Yeah. So here we see distribution of tidal forces in the passive model. Complete mutual compensation of inertia and gravity take place only in the equilibrium point of the system, or in passive model. An object placed in equilibrium point will be stretched in the longitudinal direction and squeezed in the transfer direction under action of tidal forces. So some of the transfer direction forces we can eliminate by rotation of passive model cabin and by centrifugal forces. Next. Centrifugal forces from rotation of the pilot cabin around the longitudinal axis on the frontal plane completely compensated the transfer component of tidal forces. Tidal forces only act in this case, in longitudinal direction. And this is same table. So if we can give rotation to the cabin, so we can eliminate the transfer forces component. Okay, next. Okay, here is vectors of distribution of tidal forces over the body. As you see, the distance more close to the equilibrium point, the smaller tidal forces. Longer to equilibrium point, like this is like little more 30 centimeters for the body. Bigger tidal forces. Next. And in this slide we see magnitude of tidal forces in the passive model. As you see, close to equilibrium point, the tidal forces is less than 1 G, is only 0.75 G, right? And distant area, like about 30 centimeters, it's already 3.73 G, but it's still gravitational forces that body can tolerate. So this is calculated for black hole with mass 10 to the 18 kilograms, and in this case acceleration A equal G will be 10 to the 4 meter by second square. Next. Okay. Okay, and this slide, you see extraction of energy from black hole by mechanism of Unruh and Wahl. Can you give me next slide, and we'll go back to this slide. Next. But we have a problem. Go back. Okay, no, next. No. This one. Horizon, whereas the vacuum is polarized and permanently radiate gamma quantum. So the mechanism of extract energy from black hole offered by them is like theoretical opposite from Gx and Gy. So Gx in this case have to be equal A of acceleration. And this condition will permit to same travel and acceleration and no overloading of the crew of the ship. Next. Here you see we can have this this shape in form of mechanical connections, like by some kind of material, and or we can have it without any mechanical physical connection. The connection is only by gravitational field. And this is when it's accelerating, it goes up. When it's in rest, the Earth in the central body is in the same plane. Okay, here is the movement in space, and it depends on mass. The bigger mass can fly only in space and as far as possible from the planet. But smaller mass black hole, like about 10 and 16, it could be flying even in atmospheric conditions. Here you see the beautiful sausage, flying sausage on the deep space. Okay, next. And here you see, this is a relativistic formula of speed of light according to general relativity theory, dependent of the gravitational potential, and this is how the time of spaceship. And here is the distances what we can pass. For example, to Proxima Centauri we can go full time 17.9 hours with acceleration 10 to the 5. And nearest star Proxima Centauri is 9.5 hours crossing the distance. And Andromeda Galaxy in 20.5 hours. And crossing the galaxy in 28 hours. Remember that we not violate speed of light because we use general relativity theory. Next.
So those are hours at local time for the travel.
Actually, here the time is also synchronized between Earth and ship, but this is not on this part. Okay, the time travel to smaller acceleration will be bigger. It's already takes days. Next. And this is compatible size of Starship with gravitational tandem with 10 to the 18 kilograms mass. Next. And here the heavy duty interstellar gravitational tandem is 10 and 20 kilograms. The Earth is 10 and 24 kilograms. And you can see the size of Starship. Okay, next. This is the current. And this is thank you for your attention. Do you have some questions? If you have some questions, I can do Skype connection with the author of Alexander Tsietkien, and you can ask something.